Hello, I welcome you all to this another interesting screencast. The problem reads determine the resultant force at A and the direction angles for the resultant force. Okay, this problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Alright, of course, we have force vector Fc and Fb all coming from the same point A. And we can use the vector analysis or the scalar or a combination of both. Right, I'm going to use a combination of both. So first things first, my reference is going to be A, and it's going to be 0, 0, 0, and I will have my coordinate at A. I need to draw it. So I have my Z like so. I have my Z, and then I have my X, and I have my Y. I have my Y, right? Like so, right? Okay, this is my Y. Great. Let me just wrap this point here. Great. So let me label it. So this is my Y prime. Okay. This is my X prime. This is my Z prime. Great. So let's find the position vector A, B, and AC. So we have R, A, B, and since A is our reference, we can also write this as just RB. Okay, and this is equal to what are the coordinates in the X? In the X, mind you, A is our reference. Coordinates for B with the reference with respect to A. So it's it is a 2. Okay, that's a negative, right? Negative 2i. What about in the Y with respect to A? It is a positive 4j. And what about Z? It's minus what's the height there? That's a 6, since 6 minus 2, right? Which is a 4k. All right. And then let's find the magnitude. Let's find the magnitude. This is just going to be equal to, this is equal to minus 2 plus 4 squared plus minus 4. This is just going to be equal to, where's my calculator? That's 2 squared plus 4 squared plus 4 squared. Alright, so that's a 6, root of 6. Let's find RAC. RAC, what is the coordinate in the X? It is from A, that is a 2 plus 4, right? So this is also RC. So this is just going to be equal to minus 6i Okay, this is minus 6i minus 6i. Okay, that's 2 plus 4. Then in the y, that's a plus 3j. And then in the z, that's 6 minus 4. That's minus 2k. Therefore, the magnitude for RAC, okay, its magnitude just using Pythagoras theorem is just equal to, that's minus 6 squared plus 3 squared plus minus 2 squared. This is just going to be equal to, that's 6 squared plus 3 squared plus 2 squared. So this is just equal to 7. Right. Let's write down the components. So we'll have a component in this direction, okay, and then we'll have another component in this direction, the y, okay, this direction, okay, and we'll have another component in this direction. Right. In the other one, we are also going to have a component in that direction, like so, and another component in this direction, okay, and another one in this direction. So let's label them. So this one is just going to be equal to FB times the run along the x-axis, which is just a 2, so it's 2 divided by the magnitude, which is a 6, and then this one is just FB times the run along the y-axis, which is just a 4 divided by a 6, and then this one is just FB by the rise, which is along the z-axis, which is just a 6 minus 2, so it is a 4 divided by 6. Okay, then this one is just equal to FC by FC. This is just FC by what's the run along the x-axis, that is a 2 plus 4, so this is a 6 divided by the magnitude, which is a 7. Alright, and this one is just FC by a 3 divided by a 7. Then this one is just FC by, that's a 6 minus 4, which is a 2 divided by a 7. Okay, so let's draw up a table so that we can fill in all this information. Draw a table. Alright, how many forces do we have? We have 2. So 1, 2 plus the resultant, right? Great. So there we go. So we have 1, 2, 3. Okay. There we go. Great. So we have F, we have FB, we have FC, we have the resultant, we have the X components, with units of pound, y component, and finally z component. So we said FB, x component is negative, so it's minus FB. FB is 600, so it is 600 2 over 6. Y component is positive, which is 600 4 over 6, and the z is minus 600 4 over 6. FC is the x component is negative, as a 490 minus 490 by 6 divided by 7. The y component is positive 490 by 3 divided by 7, and the y component is negative 490 by 2 divided by 7. Then we'll sum up this. So we have minus 600 by 2 divided by 6 minus 490 by 6 divided by 7. So we have a minus 620. Then 600 by 4 divided by 6 plus 490 by 3 divided by 7. We have a 610 here. And then we have a minus 600 by 4 divided by 6 minus 490 by 2 divided by 7. We have a minus 540. Let me just check through. So that one is minus 200 minus 490 by 6 divided by 7, 620. We have a 400 plus 490 by 3 divided by 7, 610. We have a minus 400 minus 490 by 2 divided by 7. Alright, so we have FRX equal to minus 620 pounds. We have FRY equal to 610 pounds, and we have FRZ equal to minus 540 pounds. So let's write this resultant as a vector. So this as a vector is just going to be equal to minus 620i, okay, plus 610 j minus 540 k. Okay. And the units for this vector expression is just pounds. Alright. The magnitude of the resultant, just using Pythagoras theorem. Okay, we have all the components frx squared plus fry squared plus frz squared. When we plug in all those values, and then you use your calculator, we have 620 squared plus 610 squared plus 540 squared. All that gives us a 1023.77 pounds. Okay, 77 pounds. Right, that's 620 squared plus 610 squared plus 540 squared. Square root of that is 1023.77. So let's find the directional angles for the resultant. We're going to use the unit vector. Unit vector for the resultant force is just going to be equal to FR, okay, FR vector FR divided by the its magnitude. This is just going to be equal to minus 620 I divided by 1023.77 plus 610 J divided by 1023.77 minus 540 K divided by 1023.77. Then we know that cos alpha FR is just going to be equal to cos alpha for the resultant is just equal to minus 20 divided by 1023.77. Okay, and then cos beta is just equal to 610 divided by 1023.77, and then finally cos gamma is equal to minus 540 divided by 1023.77. Using your calculators, we are able to find cos alpha for FR. Just grab your calculators, divide that value, and then use the function cos inverse to find the value of that angle, which is a 127.27 degrees. Then beta FR and gamma FR. Alright, so this is equal to 710 divided by 1023.77. Cos inverse of that, this gives us a 53.43. Okay, 53.43 degrees. Finally, gamma FR is just going to be equal to minus 540 divided by 1023.77. 77. Cos inverse of that, it gives us a 121.83 degrees. Alright, I guess we are done. We found the resultant and this magnitude. Okay, this magnitude. We also found the directional cosines or directional angles for the resultant. Alright, I hope the video was helpful, and if it was, give me a thumbs up, like my video, like my channel, continue subscribing and sharing my videos. Bye bye, and see you in my next screencast.